Is this visible? Can you see this presentation? Anyone? Yes or no?
No,
No,
sir.
sir.
Now?
Yes, sir.
Okay, so we will start. So in previous classes, we have seen regressor or regression model with only one variable. Okay, our output y was of this form, say some theta 0 plus theta 1 into x. So this was my input. Okay, this was my input and output is y. Our estimation is, I should write here, y cap is dependent on only input. Okay, so single input. Now we will extend this concept, and for this single input scheme, which is called as simple linear regression, or ordinary least square regression. So all the names are for the same thing. So we have calculated theta 0 and theta 1. If you remember last derivation, so we obtain this theta 0 and theta 1, or beta 0, beta 1, whatever we have called. I think we have called beta 0 and beta 1. Okay, so we have seen how to find out directly what is value of beta 0 and beta 1 for the given problem to fit a straight line with minimum squared error. Okay, so this was our problem. You will do this experiment or you will implement this in your Python and submit as a practical. I have given you the code also. Have you received that code? All of you? Have you received code? Last, I think yesterday I have sent you.
Yes, sir. We
Practical.
received.
Yeah?
Yes, sir. We received the code.
Okay, so go through that code and modify according to the problem. What you have to modify is you have to add code for reading Excel file using pandas. Okay, so import pandas as PD you have to do, and then use read Excel or load Excel file command to load that data given to you and modify the code if required and plot the thing. So Mr. Gaurav will tell you the things in practical, but thing is you have to use the same code and modify it. So let us now have this situation where output or the estimation y for the given input x is now not only depending on single x, but it is depending on many x. So x1, x2 up to xd. Okay, the estimation y is dependent on many inputs. Say y is a function of x1, x2 up to xd. This is the situation. Earlier it was f of x only. So this is simple problem. This is many variable problem or multivariate problem. Since there are many inputs going to decide the what is value of y, it is called as multivariate. You can note down this derivation on paper so that you will understand this. Otherwise, if I just run this thing, you may not be able to understand. So what I say here is you just write down along with me what is going on. Okay, so this y I cap estimation, this equation I am writing in terms of a summation like this. So same thing I am writing in terms of summation. Summation j is equal to 0 to d, that is from x1 to xd. So this j is used, and xij theta j. So theta j is the parameter to be estimated for given data. So this theta j's will decide the model performance. So if you multiply this, this will be again same as this one. So if you expand this summation, it will be looking like this. Only thing is, for the first term there is no xi0. So this xi0 actually is always 1. Okay, so here I say it is 1 multiplied by theta 0. So this 1 I call now xi0. Okay, if I do that, then I can write in compact form or in matrix form. So this is simple adjustment. Now see what happens if I do like this. I can write estimation y cap directly as x into theta. So same thing I am writing in terms of now matrix multiplication, matrix multiplied by a vector. So what is x now? X is this particular matrix, which consists of x1, x11, x12 and so on up to x1d. So it is a collection of all inputs. So this is sample 1, sample 2, sample 3, okay, so on. So if you take this first row and multiply with this column, you will get y1. Okay, if you take second row, multiply with this column, you will get y2. So then y3 and so on up to yn. Okay. Now only thing is that the first position of my matrix is always 1. Now why this is always 1? Since xi0 is always 1, so I have to keep that position always 1. Okay, so this position is 1, this position is 1, this position is 1, so that is reflected over here. And why this is 1? This is just a trick to convert this complete equation into x theta format. Okay, so this complete equation we are just writing as x theta, and to do that we require here x say 0, and this is not present, So what we write, x0 is always 1. Okay, so that this will be just theta 0. So there is no harm in doing this. So that's why we are doing like this. So if I do this, then my matrix looks like this. Now next thing is the objective function to be minimized is j theta. You note down this j theta is
Sir,
to be
are you
minimized.
presenting something else? Because PPT presentation is visible to us.
Pardon, can you repeat?
Sir, PPT presentation is visible to us. Slide of gradient of error.
Okay. This is not visible. Can you see now?
Yes, sir. Now we can see.
So just inform me if something is happening like this. Because I will keep on talking and you are not able to understand, then that will be difficult. Just interrupt me anytime. No problem, right?
Yes, sir.
So have you seen this earlier equation or so? This was visible?
No, sir.
This you could not see?
No, sir.
So shall I explain then? Just 1 second. Okay, just see this one. I started with this equation today. This is my linear assumption. This is my assumption that my estimation model will take help of just 1 second. Now is it visible?
Yes, sir.
Okay. Now what I am saying here is today that if this is my regressor, my input is capital X, that is a vector consisting of many variables. So instead of single variable, now my estimator has to estimate, say y cap is equal to f of capital X. Now this capital X is a list of variables. Okay. Now this function f, I assume that it is a plain kind of a thing, simple linear thing. So I assume that my estimation model is of this form. Is this clear? So my estimation model is of a linear form. In earlier case it was y cap is equal to theta 0 or beta 0 we have used, theta 0 plus theta 1 x. So this was our earlier derivation. Now instead of only one variable, suppose my output depends on many variables. Okay, so the many variables I have incorporated here as x1, x2 up to xd, and their contribution in estimating y is theta 1, theta 2 up to theta d, and theta 0 is the biasing term. Theta 0 here is the biasing term, like y is equal to mx plus c. C is called as the biasing, or it's a constant. Okay, so that you can adjust the line position. Now here theta 0 will do that job. It will try to adjust the line position, and then all these thetas, theta 1, theta 2, theta d up to theta d, they will try to adjust the slopes or orientation with respect to that axis. Now this thing we can write in compact form like this. So this whole equation number 1 you can write as equation 2. So if you expand this equation 2, which is summation j0 to d, it will look like this. Only thing is this xi0 need to be defined. So xi0 is not present here. Only thing which is not present over here is this xi0. So this I am keeping always to 1 so that equation 1 and equation 2 will be same. That I have to keep in mind. So if I do that, then this summation I can write as multiplication of two things. One is a X matrix and theta is the parameter vector. So this is matrix X and this is vector theta. Now if you go inside this matrix X, you will see that this first column is always 1, so that this xi0 equal to 1 is accommodated. Okay, so this will be always 1. So if I do this, then I have done the modeling. Only thing is I need to find out values of theta. If I find out values of theta for my problem, for my samples, then job is done. Okay, so only thing I need to find out is theta 0, theta 1 up to theta d. So how to find out that we will be
Sir,
doing
now
with the
your
help.
pointer is not visible.
What is not visible?
Pointer.
These red markings are not visible.
No, sir.
Okay, then what I should do? Can you see now?
Yes, sir.
I think there is some problem, technical problem. I don't know why it is appearing. Now see that only thing is I need to adjust this or obtain these values of thetas. Now how to do that I will tell you. The objective function to be minimized, is this visible? Next slide.
No, sir.
No, sir.
Now,
Yes, sir.
is this fine?
Yes, sir.
Good. So objective function to be minimized is some j theta. So we call objective function as j theta. So this j theta is equal to summation I equal to 1 to n. N, small n stands for all number of samples. Number of samples. Is my pen visible now?
No, sir.
No, sir.
It's difficult. Now,
Yes, sir.
so let us keep the slides like this. Can you see now?
Yes, sir.
Okay, so see this equation which I am marking now. This is called as objective function, which is equal to I equal to 1 to n, that is all samples. We have to fit a straight line or a plane. Actually it will be plane because since this is a multi-dimension thing, so we have to fit a plane or hyperplane such that the original value of y for given input, so for if input is ith input, so it will be xi. So for xi input, estimation will be yi cap. Suppose x, estimation is y cap, and its true value is known to us because while training for given input x, what is expected value of x, what is expected value of y is given to us. So the difference between the estimation and actual value square is my objective function. So objective function is we have to minimize this j theta for all training samples from I equal to 1 to n such that this difference between estimation and actual value square is minimized. So this difference square we can write in terms of vectors as y minus x theta. So what is x theta? X theta is equal to estimation that we have seen in last slide, say this one. Y cap is equal to x theta. So what I have done is for y cap I am replacing as x theta. So y minus x theta transpose y minus x theta is nothing but j theta. Okay, so this we will take help in next step. Up to this, is it fine? It is just matrix or vector, you can say multiplication. So this is actually norm square of a vector. Okay, so what I want to do is I want to minimize this j theta defined like this. So what we will do is we will differentiate this j theta with respect to theta and equate to 0 so that minimization will happen. Now see this step carefully, even you can write down these steps. So differentiation of j theta with respect to theta. So this is equal to dou by dou theta into y minus x theta transpose y minus x theta. Okay, so this you will expand. So once you expand, it will be looking like this, the second step. So it is y transpose y minus y transpose x theta minus x in theta into x theta transpose into y plus x theta transpose into x theta. So if you simplify this, it will be y transpose y minus 2 into y transpose x theta plus theta transpose x transpose into x theta. Okay. So next. Now next step is equate this simplified version to 0. So if you equate this to 0 and further simplify for theta, you take this thing to right hand side, this first bracket, you can take this to right hand side. So theta is equal to x transpose x inverse, because I have to multiply this by x transpose x inverse to both sides. So this will be equal to x transpose x inverse into x transpose y. So don't worry about this. I will take one example so that the things are more clear. So we can directly obtain all values of thetas in one go. So theta 0, theta 1 up to theta d we can obtain directly in one stroke for a given problem. Okay, so if x is of small size, it's easy to obtain the solution. If x transpose x, and one must be aware that x transpose x must be invertible, so it should not be rank deficient. That means x transpose x inverse should exist. Okay, so that is the only condition, otherwise you can get the solution in one go. I just repeat what I have said so that those who could not see earlier, they will be comfortable. So what I have told you today is a simple thing. So estimation yi cap is equal to theta 0, theta 1, x1 plus theta 2, x2. So this is my model. The model which estimates some value y, provided input is x1, x2, xd. I repeat that in last class what we saw was a simple model, linear model with only one input variable, now I am having many input variables. So x1, x2 up to xt. D can be any number. Okay, in that case we will be fitting a plane or a hyperplane instead of simple line. So last time we have seen fitting of a straight line like this. So these 5 samples were given to us, then I was fitting a straight line like this. Now there was only, here it was only one dimension on x-axis and y was the predicted value. Instead of this, now I have many inputs. Okay, so it will be multi-dimension case. So what I did, I just write that equation in this form and then convert that equation into a matrix form. So y cap, the estimated value of y, is now equal to x theta. So x theta, where x is of this form, 1, x1, 2, then up to x1d, then again 1, x2, 2, up to x2d, and so on. So like this will be x matrix. Now next thing I did was I just defined an objective function. What is objective function? This is the function which will help me to fit the proper plane at proper location and position. So how this is done? So we calculate the actual error because of the fitting. So suppose I randomly fit somewhere with some initial values of theta, then the machine will start predicting as per the fitting, current fitting of the plane. Right? So then I estimate something for a given input and I compare with actual value. So actual value is given to me when it is training phase. For training phase, I know what is yi. Okay, for a given input x, I know what is yi. I can use this equation, first one, to compute estimated value. Then I take the difference between estimated value and actual value. I square it. Okay, because difference can be negative, difference can be positive. So if I add all the differences, then it may happen that difference addition is 0, but actually that is not the case. My fitting is not proper. So what we do, we just square the differences so that this positive negative thing will not exist. Everything is now positive since I am squaring it. So once I square it, then I add all the differences that are appearing for all the samples. So this j theta will consider the error square for all the samples. Now that I have to minimize, so I will differentiate this j theta with respect to theta and equate to 0. Okay, so that is what we have done. Now let us take one example. Is this example visible to all? Is this visible?
Yes, sir.
Okay. Now see, the example is design a linear predictor using following data. So outside temperature is one variable and number of persons in a room is another variable. So there are two variables, say this one and this one, second one. These are two inputs and what we have to predict is power requirement of the room. Okay, is this clear? So the y is this power requirement. Y variable is this power requirement and x1 is suppose outside temperature and number of persons in a room is x2. So what is given to you is if outside temperature is 10 degrees Celsius and number of person in a room are 2, then power requirement is 0.5 kilowatts. Second data sample is saying if outside temperature is 5 degrees Celsius, number of person in a room are 42, then you require 2.5 kilowatts. Okay. Then we have 4.5, 31 person and 2.2. Then 6 degrees, 35 persons and 1.8 requirement. So this is actual data given to you. Now what you have to do is you have to now start predicting. Suppose I say outside temperature is 7 degrees Celsius and number of persons sitting in a room are 25. Then what is power requirement? So this is not given in my table. So I have to now estimate this based on the data available. So this is a very good example to understand what is the power of prediction. So this data is not available right now. So what I assume that with the help of these 4 samples, I assume that relation between power requirement, number of person and outside temperature is linear. Okay, so they are linear in relation of this form, the first equation. Okay, so here power requirement is equal to some theta 0 plus theta 1 into temperature of the room plus temperature outside plus theta 2 into number of persons in the room. So that is my relation. With this relation, I want to find out what are the values of thetas so that I can then start predicting. So what I do now, I write my y values. Okay, my y values are this one 0.5, 2.5 and 1.8. So I should write here, there is some mistake I think. Okay, so you can correct this. So this is outside temperature as my input. I have to write here properly. So this should be 0.5. So this should be 0.5. 0.5, then 2.5, then it should be 2.2 and 1.8. Okay, then you have this X matrix. You have this X matrix as 10, 5, 4.56. So I should write here 10, then 5, ten, 5, 4.5 and 6. So this should be 4.5 and this should be 6. Okay, then I am writing the second column. It is 242, 31, 35. So 242, 242, 31, 35. Okay, so 31, 35. So this will be my X matrix. Is this clear? Any confusion here? What I have done? This will be pretty simple, straightforward. Somebody is saying what is X matrix? So X matrix is required to calculate theta, which we have seen earlier. So this is my X matrix, where X matrix is collection of all training samples. Okay. X is collection of all input actually from training sample. So in this example, the outside temperature and number of persons in room, these are input variables. So output depends on, I can write here, output depends on, so just one second. Say output power requirement suppose is equal to, so this I can call as y because my y is output. So y is power requirement is equal to some theta 0. So theta 0 I don't know because that is to be estimated. So it depends on the some theta 0 I have to search 1 minute. So for timing I can use some other symbol like beta. So this beta 0 plus beta 1 into outside temperature plus beta 1. So I am writing instead of theta beta. So you have to keep that thing in mind. Number of person. Okay, so this is what is my estimation or my assumption of the model. Now thing is that I don't know what are the values of beta 0, beta 1 and say here I should write beta 2 for this model. Now I will take help of these training samples available to me to estimate or to find out beta 0, beta 1, beta 2 such that squared of the error is minimized. Okay, so for that I take this y is equal to this vector. So y will be collection of all the training, all the actual predicted, all the y values from the training samples. So this power requirement for first sample is if temperature is 10 degrees Celsius and number of person are 2, then power requirement is 0.5. So this y value, say I can call this as y1 is given to you as 0.5. So this is y2 is equal to 2.5. So this is given to you like that. Y3 and y4 are also given. So if I collect all y values, it will be a y matrix, a y vector. Then I just write all ones at the beginning of this X matrix so that this theta 0 multiplicand problem is solved. So that I have shown you here. So this theta 0 do not have any X associated with it. So I will write that value as 1. Since there is nobody here, I can write easily 1. So this 1, 10, 2 is nothing but my data. So this first row I am writing here as 10, 2. Then I write second row 5 and 42 as 542 here. Then third row and fourth column, fourth row. So like that I can keep on doing for number of samples. Now from derivation I know that what is theta 0? Theta 0 is x transpose x inverse x transpose y. So if I do this with the help of any software, I can easily find out the value of theta. So I have to check this value because there was some problem here. I will tell you the value next time, or you can even try for this. So similar to earlier program, I will also give you this program of Python where you will be writing this. I have to correct this actually. Okay, so this code I have to correct for values, otherwise code is perfect. So this y values I am writing here. So this will be y value entry. Then x value I am defining from the data. So this y and x are defined. Okay. Then I find out x transpose x inverse. Then I find out x transpose y. And then I directly compute theta is equal to x transpose x inverse into x transpose y. So I can simply implement in one line this formula theta equal to x transpose x inverse x transpose y. So this you can do in one line in Python. Okay. So if you do that, you immediately get values of thetas over here like this, and then you can start predicting. So more on this I will tell you maybe tomorrow or in next class. So what I suggest you is go through this video today, and once again the first video if possible, and be ready for a small test tomorrow. I will conduct a test. You will do this solving for yourself and write the answer. Okay, so that you will have a practice of this, and even you can write a good program on your own. So this I am intentionally forcing you to do, so that once you get aware of the terms and then you get aware of the Python, later on you can do your own programming for projects also. So you have to do little bit hard work at the beginning, but things will be easier once you are familiar with this. Okay. And I have talked with Professor Bhalera. So he is doing correction of your timetable today. So that will be done today. Since he was on leave, so he could not correct it earlier. Second thing was your practicals.